happened is we have, I did all those science presentations on here, and they're really long, right? I mean, it's like a solid 2 hours worth of,
Whoa.
videotaping, and I think it's taking up space on the computer or something. So when I deleted stuff, it looked funny. Okay, so what I'm going to do is I'm going to write a problem down on the board. We're going to talk about age word problems. This is part 2, right? Part 2, where I'm just going to be, there's a couple more curveballs, and so you just want to see how they work in these different things. So make sure in your notes you write down everything I write down. So let's write down the word problem as I'm writing it. I'll say it out loud so you can just copy it. So this is the first one we're going to do. So Gary is 50.
You are? No.
And his son, we'll do 2 of these, and his son is 18. In how many years? It's almost true. It's not quite. In how many years will Gary be twice as old as his son?
Well, he already is.
Well,
perfectly.
50 twice times 2 times 18 is not 50.
Well, yeah,
Well, then
but that it can't be possible then.
Well, that you're looking at the now figures. We're talking in how many years?
Well, then you
Right?
would have to stay the same age, and your son would have to
That
age.
I know
vice versa.
exactly what you mean, because when I first did these, my brain worked just like yours, and I thought the same thing. This is ridiculous. This is totally impossible. But it's not impossible, and you're going to see. So we got to start with our
Chart.
chart, our box, right?
Chart, baby.
Oh, we have our box.
Chart, baby.
Okay, guys, let's remember this is a video. So this is Gary, and this is son, right? And we've got age now. This is the age now. And now it says in how many years? Huh. That's interesting. What's my column here? Is that plus X or minus X?
Plus X.
Does everybody get that? Do you see that? Because it says, instead of if it said in 4 years, I put plus 4. If it said 5 years ago, I would do minus 5. If it says in how many years,
Plus X.
it's plus, because it's future, and then it's X. If it said how many years ago, it would be minus X.
Wait, Gary, wouldn't
right?
you have to do like, and your son would be 20 because then it would be possible because in then 10 years you would be 60 and your son would be 30 and that would be possible.
Right, that's
but
possible. Well, maybe this one's not possible. Let's just try. Let's see.
Is your son
So
named
the
Brad?
question is, what do I put in my now column?
Is your son named Brad?
What?
Is your son named Brad?
No, it's in his Jamie. Is his name.
Oh,
James.
yeah.
James or Jamie. So
I
what?
didn't know that. I was just guessing.
So now I'm looking at my very first line, my first sentence. Gary is 50 and his son is 18. How do I put that into my chart?
50,
Dee Dee.
18. You put yourself as 50 and you put your son as 18.
Oh wait, there's no X.
It doesn't matter because you already have an X. Like if you're
Oh, the X is going to be in this column. Oh, that's interesting,
50
right?
plus X.
So this is going to be 50 plus X, or you could do X plus 50, right? I like my X first personally, if I can. And then this is going to be 18 plus X, or X plus 18. That's how I prefer it. All right. Does that make sense? That's pretty straightforward, right? Right? That's not a big curveball. They just actually gave you their actual ages for now, and then it's the future ages that we don't know, right? Okay, so now it says, now we've got our second sentence. In how many years? So which column am I going to have to use?
X.
This column. I got to use this column. And whenever it says Gary, I'm going to write X plus 50. And whenever it says son, I'm going to write X plus 18. So it says, in how many years? Now, one last thing. This is written as a question. And it's easier if you turn it into a statement. Instead of saying, will Gary be twice as old as son, put it Gary will be, just so that I'm turning it into a statement instead of a question.
This one and then this one.
So right, so I'm going to change it since instead of in how many years will Gary be, I'm going to say in how many years Gary will be. So then Gary is x plus 50, right? Will be, what do I write for will be? Equals, because that's a tense.
This is the food.
It's the future tense of the to be verb. All right, Gary will be, how do I do twice?
Two.
Parentheses.
Two parentheses. All right, as old as his son. His son is, or will be, x plus 18. So I write x plus 18, and now I just solve my equation for x. Now what am I going to get when I solve for x? Yes.
X equals 14.
But what will that tell me?
In
How
14
many
years.
That's, yeah, actually, this is what my x represents now. In how many years, right? And then I don't know the answer, so you're saying it's 14, we'll see. X plus 50 is equal to 2x plus 36, right? And then we're going to subtract x, right? We want to have our x's all on one side. And then I have 50 is equal to x plus 36. And then I'm going to subtract 36. Subtract 36. And then I have
24.
14.
Oh my god, it is possible. What?
14 is equal to x. Look at that.
And
So let's
Possible though.
so let's make sure.
Well,
14 in how many years? When I am 64,
your son
right?
will be 32.
Jamie will be
32.
20, 32. 32 plus 32 is 64. Look at that.
That's
Oh my
weird.
God.
Wow.
Oh, you know that
Crazy.
So I'm done, right?
Wait, Gary,
No.
No, you're not.
I'm not done. So I have to say, Gary, they asked it in words, I have to answer in words. Gary, oh wait a minute, I'm sorry. I forgot what I was saying.
26.
In how many years? In 14 years.
In 14.
I don't know.
In 14 years, right?
In 14 years.
In 14 years. You could just
The
say in
world would
14 years.
die.
That's fine.
Wait, Gary, how old is Jamie now?
14 years.
I actually think he is 18.
Nothing will be different.
Gary, how old are you?
Oh.
64?
In 14
I'm 23.
He's 21. He's 21.
Gary,
No, you're
he's
58.
Can I erase this? Oh,
Yes.
okay. Phew.
Gary,
No, do not erase your notes. Okay, so now the next one. Let's try one more like this so that we're sure we got it.
I'm being positive.
What time is it? We're doing great. Okay. Number 2, here's our second one. So write it down as I'm writing it down so that we're done. When I'm done, Skylar and Manu, I want you to write this down as I'm writing it down. So when I'm done, you're done. Okay?
Okay, Gary.
I will read it out loud. So Peter
Peter picked a piple papple
is
pickles.
29 and his friend Paul
Yeah, I have a friend named Paul. I
And
actually
his
have an uncle named Paul.
Friend. Paul.
is 21. Guys, there's no way you guys can be writing this down,
Be quiet,
Skylar,
people.
while you're talking and making
Oh my
jokes.
gosh.
Okay?
He's 21.
Peter, guys, I want it quiet. I want you to write it down while I'm reading. Peter is 29, and his friend is Paul is 21. Okay, how many years ago was 5 times Paul's age equal to 3 times Peter's age?
What?
Jinx.
Makes sense.
What? No, it doesn't.
Makes 0%. Davey is the only one who
We
understands.
need 21
So,
somewhere.
so guys, we immediately need our box, right? The box helps us to order our information, and it makes it very easy to solve when you have your information organized.
Let's all make a box.
So I know I have Peter and Paul. So we have Peter here and Paul here. I know this is my age now,
21.
right? And I know this is my, okay.
Minus X,
It
right?
says how many years ago? What will I put for that?
Minus X.
Minus X up here. Okay. So what do I put in the now column?
29 and 12.
29, and Paul is 21.
Okay. And what do I put in this column?
21 minus
X.
Yes, 29 minus X. In this case, you want to put the negative X at the end, right?
Yeah.
And then 21 minus X. Otherwise, you'd have negative X plus 29, negative X plus 21. I'd prefer to write it like that. Okay? All right. So now it says how, so we finished the first sentence. That's all done. So we have to now do the second sentence. It says how many years ago? That means I'm going to have to use the minus X column, right? Pretty clear. And then I'm going to change this into a statement. It says was 5 times Paul's age equal to 5 times Paul's age was equal to 3 times Peter's age. So I'm going to put the was right here, was equal to, right? 5 times Paul's age was equal to, so we're going to 5 times Paul's age. How do I do 5 times?
5
By parenthesis, what's Paul's age?
21 minus X.
21 minus
Oh,
X.
yeah, 21 minus X.
Okay, it says 5 times Paul's age was equal to.
3 times.
Was equal to.
Equal sign.
Equals, right. Okay, and then 3 times Peter's age. How do I do 3 times?
3 parentheses.
29
And Peter's age is 29 minus X.
minus X.
Oh, that's so smart.
Pretty cool, right?
Yeah.
This would have been hard to do with the guess and check method.
Yeah.
It really would have been, right? A lot of them are not hard to do with the guess and check method, but this would be kind of tough. And so algebra is our savior, right? It's going to be awesome. So now, oh shoot, what's the name of that property? I forgot.
Distributed.
Oh, that's it.
property.
Okay, so I'm going to do my distributed property.
It's like newspaper.
5 times 21.
Or
105.
Who knows their-
5 times 21 is 105.
105. Thank
Wait.
God for mathematicians.
105.
Okay. Minus 5x is equal to 3 times 29.
I don't know.
I have no
Everyone
idea.
teach me.
3 times
87.
3 times 30 is
87.
Use that count.
87.
I
okay. Now guys,
87.
it's too
Wait,
noisy.
this is impossible then. But
It's
why?
too noisy. Guys, this is my lecture. It's too noisy.
Just minus
Okay.
100.
So now now let's look at this equation for just a second.
Oh.
This is a little bit
Impossible.
strange, this equation.
It's gonna be more years ago than they're alive than they have been alive.
Really?
Maybe, maybe not. We'll see.
Maybe it's a paradox.
I don't want to do that.
But
Oh, I got
focus,
the answer.
guys, focus on the equation right now. We have 105 minus 5x equals 87 minus 3x. What would be your next
Oh,
one?
you have to add 3x. Wouldn't you
Or
know?
add 5x because then you would have a positive x.
Yeah.
If you add 5x, then you'd have a positive x.
So
which
Manu,
would be a positive
Manu,
2x. So
stop.
it'd be 105
Skylar, turn it forward.
87
This is my lecture.
plus
Because,
plus
okay?
2x.
Yeah,
What's that make
if you add 5x, then
You're
instead
gonna add
of having 105 plus a negative 2x
Well, then,
equals
no, but-
87, but if you add positive 5, that one, then you'd have 105 equals 87.
So
plus
clearly,
2x.
You couldn't
so
have
clearly,
105
guys,
plus negative 2x. It would just be 105 minus 2x.
Oh, yeah.
so clearly we have x's on both sides of the equal sign, right? But we got to get them on the same side, right? Now, how many people think I should add the 3x to both sides? Don't all raise your hand at once, okay? All right, how many people think I should add the 5x to both sides? Do you see the difference? If I added 3x, look at this. If I added 3x, don't write this down. It works. It totally works. This is totally legal to do because the golden rule of algebra says whatever you do to one side, you can do the other. Totally fine. But look what's going to happen though. If I did this, look what's going to happen. When I draw my line, what's going to happen? What's negative 5x plus 3x?
It's going to be negative 2x.
Negative 2x. That's okay as long as you're comfortable with dealing with negatives a lot, right? But in general, as a math teacher, I will just tell you, most people make the mistakes when they're dealing with the negatives. That's where the majority of the mistakes happen. So if you have negatives, you have to sort of slap yourself a little bit and wake up, wake up, But
Ow.
I would rather take the smaller number. Which one's smaller? -5 or -3?
-3.
-5 is smaller,
Oh, yeah.
right? I like the smaller number. So I'm going to add 5x to both sides, add 5x to both sides. And then suddenly I have 105 is equal to 87 plus 2x.
Great X, Gary.
Thank you.
Yawn time.
All right, and then I subtract my 87.
X
Subtract
equals
my
9.
87.
X equals 9.
So what does that equal?
18.
So that's a 9, right? And this is 15, so 8 and 1. That's
Divide
right.
by 2, divide
I
by
told you.
Equals 2x.
Man.
Divide by 2.
Divide by
X
2.
is equal to 9.
Oh my god.
9 years ago.
Right? That makes sense?
9 years
You didn't see what I did? So, I, so Skylar, why are you guys next to each other? Oh, because you asked. But you asked. I gave you specific permission to sit here, not to talk to him. Is that clear?
Yeah.
Okay. So make sure. Otherwise, you're going back. Okay. All right.
Okay.
So 105 is equal to 87 plus 2x. I subtracted 87. 18 is equal to 2x. Divide both sides by 2. I get x equals 9. Right?
Yeah.
So what does that mean? How many years ago? So my answer, my x is up here. That's 9 years ago would be my answer. So I
9
write
years ago.
9
5
years
times
ago.
Paul's age was equal to 3 times Peter's age. Oh my god.
Right? 9 years ago. Does that make sense?
So crazy.
What about the other way then?
Right?
So there was a different way.
Well, you
Well,
still get the
you
same
could
answer.
you'll get the same answer. I could have added 3x to both sides, and then I'd have negative 2x equals stuff. And it would probably end up being negative 2x is equal to negative 18. Divided by negative 2, I get positive 9.
Okay.
See what I'm saying? It's just easier to deal with them positive if you can. Yes, Issa.
Do you, like, it said, like, here it says then 105 minus 5x equals 87 minus 3x. Do you mind if we just, like, and then we get, like, 87 plus 2x equals 105. Do you mind if we, like, switch it around so that all
No.
the x's are on the left? And then-
Totally fine. Think about it. 105 is equal to 87 plus 2x. They're the same thing, right?
Yeah, so,
So it's totally fine to just go like this, equals 105,
okay, yeah.
right? And then suddenly I have my x on the left. It's totally fine to do that. Okay, can I erase?
Yes.
We have, okay. Now
Can
the
we do
next
one more?
one is this one really wasn't that hard, right?
No.
It's just different than the others because the others, they didn't tell you exactly what the age was now. They said Paul is 6 times more than Jim, right? Things like that.
And Jim is 85.
So,
Because his name is Jim.
we need a better eraser.
Jim is 85.
Eraser.
Gary, what we need to do is clean all.
Well, no,
this.
it's the eraser that's like all.
I know, I don't know how to clean these erasers.
You just take a paper towel and like hit the eraser with it a lot of times.
Oh, really?
Well,
Okay.
there'd be like a razor dust anywhere.
Alright.
So you look like oh my.
Now, okay, let's see. Let's write the third problem. Here we go. The sum where am I? The sum of the ages
Okay.
of John and Louis
It's pronounced Louise.
is 36 years. In 4 years, comma, Louis will be 4 times as old as John is. 4 times as old as John is. How old is each now?
Oh my god. No.
So when you see, sorry, when
was like a bird out.
It did.
when you see this, this is a really important learning, right? A really important part of the lecture. When you see the words, the sum of the ages of two things, or the sum of two numbers is,
It's
right? That is immediately in algebra, your brain kicks in and says, oh, I know what it is. And this is how you figure it out. If, when it says, I'm going to just give you an example. Put this separate from this problem, right? We're about to do this problem, but I got to teach this part first. The sum of two numbers is 14, right? Now, let me ask you this. If I said the first number was 13, what would be the second number?
1.
How did you get that?
We subtracted 13 from 14.
So you did the total of 14 minus the first number. Am I right?
Yeah.
Yeah.
Okay, so we got 14 minus 1. I mean, excuse me, what did I say? 4 minus 13, and that equals 1. Yeah, that makes sense. Okay, what if I said the number was 7? One of the numbers was 7.
7.
What would be the other number?
7.
7.
7. So let's see, we would have to take the 14, the total, minus the first number, 7, and that would give me 7, right? Does that make sense so far? It works. So what about if I said 4? Let's say the first number is 4.
10.
10.
All right, how'd you get it?
14 minus
The
4.
total minus 4, which is 10. Okay, what if I said the first number was x?
14 minus x.
It would be y.
It would
It'd be
be
14 minus
It'd
x.
It'd be
14
algebra.
It'd be 14 minus x.
algebra.
No,
It'd be
yes,
algebraic
yes, it would be. Yes.
So it would be the total minus the first number. It's whatever's left over when you subtract the first number from the total,
Which
right?
is 14 minus
Right?
x.
So it's going to be 14 minus x. It's not x minus 14. It is 14 minus x. 14 minus x, so the other number is 14 minus x. Does that make sense?
Yep.
You see that?
Oh my
So,
God.
so I'm going to reword it. I'm going to say it again. When the sum of two numbers is something, like 14, the first number, and I don't know what they are, the first number is always x, and the second number is whatever's left over when you subtract that x from the total. 14 minus x. Does that make sense? That gives you your two different numbers. You get it? So, the sum of two numbers is 10. What are the two numbers?
5 and 5.
X and then x minus 10.
X and no.
10
Or
minus
10
x.
10 minus x. Sum of two numbers is 8. What are the two numbers, Skylar?
X minus.
X is your first one. And then
And then 8 minus.
sum of two numbers is 8.
It's
So-
x. It's 8 minus x.
Yes, it's x and 8 minus x. The sum, John, sum of two numbers is 22.
22, 11, 11.
The sum of two, you don't know that the first one's 11. The first one's x. You don't know what it is. So the first number is x. The second number is the total, whatever's left over when you take the total and subtract x from it. So 22 minus x is your second number. Did you not see this? Did you get this? You were daydreaming.
Kind of.
Kind of, you get it? So think about it. If my first number was 13, to get 14, I took my total and I subtracted my first number. It's whatever's left over after I subtract my first number from the total. It's 1. If the first number is 7, I would take the total minus the first number. That'll give me my second number, 7. The first number was 4, I take my total minus 4, subtract 4 from the total, I get 10. That's my second number. If my first number, if I don't know what my numbers are, my first number is x, and my second number is the total minus x, 14 minus x. Does that make sense?
Yeah.
So that's my second number. First number, second number. So sum of two, Amaya, sum of two numbers is 2.
2 minus x. And 2 minus x.
Well, the first number is x.
Wait, what?
What are the two numbers? The sum of two numbers is 2. The first number is x. The second number is 2 minus x.
Yeah, that's what I said.
Well, you just said 2 minus x.
Oh, sorry.
Yeah, I'm saying the first number is important too. Bella, sum of two numbers is 30.
So x and 30, which is 30 minus x.
Yes. Okay, Sam, sum of two numbers is 21. Think about it. Sum of two numbers is 21. First number is always, right? And the second number is the total. What was the total again? The sum of the two numbers is 21. The second number is 21 minus the first number, x. 21 minus x. You got it? Right? So that's the key. So now, sometimes though it's not written as the sum of two numbers, it might say the sum of two ages, right? It's the same thing. So we've got here, we got to create our box. Let's create our box. Okay. So we got now, we have, who do we have? John and Lewis. John and Lewis.
No, it's not. No, when
No,
Louis.
Louis when you
W
have an
not.
O-U-I-S.
No, Louis is when you have an L-U-I-S.
Oh,
Then it says, guys, then it says
L-O-U-I.
in 4 years, plus 4, right? Okay, so now, okay, all it says for now, it says the sum of the ages of John and Lewis is 36 years. It makes no difference which one I make x. No difference at all. I will get the right answer either way. So which one do you want to make x?
Lewis.
Lewis,
Yeah.
okay, Lewis is x. What is John?
36 minus x.
What is John?
is
The sum of their ages is 36.
36.
So it's whatever's left over when I subtract this from the total, 36. 36 minus x.
Plus 4.
You guys
So-
get that?
It's 30x.
Now plus 4. What's 36 plus 4?
40 minus X.
40 minus x. And what is x plus 4?
X plus 4.
Oh, yeah. Good job. Okay. So I did that in my head, too.
Gary.
All right. So it says, in 4 years, I'm going to use this column. You agree with me?
Yeah.
Lewis, what do I write?
X
X
plus 4
plus
Okay, x plus 4.
will be
Okay, will be, what do I write?
equals
Equals. 4 times, what do I write?
4 parentheses.
4 parentheses. As old as John is.
40 minus
I'm
x.
sorry, 40 minus x.
And then close parentheses.
40 minus x in parentheses. Okay. Okay, there we go. That's my equation. Double check. Sometimes on a test, good idea to check. Let's see. In 4 years, Lewis, yes. Will be equals 4 times as old as John. John is here. Yes. That's it. So now I'm going to solve it. X plus 4 is equal to, I use my distributive property, 160 minus 4x. Now, what would I do? What's my next move?
Plus 4x.
Plus 4x. That's the smaller number of x's. This is a whole 1x.
5x.
This is a whole negative 4x's, right? So we're going to add 4x to both sides. Add 4x to both sides. Draw my line. I've got 5x plus 4 is equal to 160. Am I right?
Yeah.
And then subtract 4. This is weird.
This is going to be a weird number.
Yeah, why is this not working? Did I do something wrong?
I don't think so.
No, it's 5X equals 156.
Okay,
And then
5x is
3,
equal to 156. Huh, well, I'll have to revise my,
X equals 31.
I'll have to remember to change. Okay, fix this. Okay, so if I divide by 5, hopefully, I think the ones
get
I'm giving
31.
you are going to work out evenly, okay? But this one didn't.
You
So
get 31.2.
x is equal to, did I do something wrong?
No.
I added 4. It's in 4 years, added 4, 36 plus 4.
We're
Weird.
just supposed to do like 9.
Okay, whatever. I'll fix it. I'll fix it someday. So whatever that is, 5 goes into 15 3 times.
It's
5 goes into 6
31.2.
once, and something else, 1/5,
0.2.
right? Or 0.2, right? Either one. And then I could say, okay. So the question is, in Lewis will be 4 times as old as John
And
is
31 and a half
in
years.
31 at 0.2 years. Lewis will be,
In 31.2 years.
yes, okay, it
But
works.
wait, the question is how old is each now?
Oh, yeah, you're right. So Lewis is X, right? It says X equals that. So Lewis is 31 point, did I just say in 31.2 years? No, sorry, that wasn't the answer. Lewis is 31.2 years old and John is 36 minus 31.2, right?
So
Whatever that is.
That age.
That
And
age,
32 my, oh,
John is one age and Lewis is another.
right.
yeah.
Now, the key though, the only part that's hard on these is that first sentence. The sum of the ages of John and
is
Lewis is 36,
4.8.
and it's really easy. It's just X and 36 minus X.
John is 4.8.
Okay?
8 months.
All right, Vista 5. Did you understand that?
Yeah.
Vista 5. I really want to see it right now.
So what do you
Okay.
write for your answer?
John, did you get it?
Yeah.
Vista 5? Vista 5? Okay. Skylar, Manuk, I haven't seen yours. Okay. All right, good.
So what do you put in words?
So those are the kinds, you're going to get the front side will be like the first two examples I gave you and some of the old ones like that you've done, right? The first side will be sort of easy. The second side are all of the homework are all going to be like these where it says the sum of the ages, right? I believe I think I might have put some that it says the sum of two numbers where they're not they're not age problems, they're just number problems. But if I do that, let me just quickly, but I think you'll know how to do it. I think you'll get it. The sum, like the set number 7, it says the sum of two numbers is 22. Immediately I know my two numbers are X
And 22 minus.
and 22 minus X. And then it says 5 times the first number. Doesn't matter which one's the first number. You can either use X, Skylar and Jackson, I'm explaining homework right now. It says the sum of two numbers is 22. I've got X and 22 minus X. And then it says 5 times the first number. Doesn't matter which one's the first number. Either X or
Gary's still recording.
22 minus X. Yeah, it is. So I'm giving you the answer, right? Okay, awesome, right? So I got 5 times X or 5 times 22 minus X, whichever one you want to do, is equal to 4 less than the second. So the second number and then minus 4. You get it? Sort of? Don't worry, you'll see it when you see it. But I just explained it on there. That's number 7 on the homework.
Wait, what was the answer? The number 7?
I am not giving you the answer. That's the number 7.
Why?
Oh, well, yes, you did. Okay. All right, so that's it. That's the end of the lecture.